Hello, welcome everyone. And today we are going to see why we should use C and its importance in embedded systems. Today we are going to understand one of the most important foundations of embedded systems, the C programming language. Even though the world has Python, Java, Rust, Go like that many other languages, but still C is the backbone of 90% of embedded system devices around us. In this presentation, I'll explain why C is still the king, where it is used in real life systems, why companies like Tesla, Mercedes-Benz, Bosch, Samsung and Apple rely on C, and how you need to build a strong embedded career within it. And today's our agenda is why C is number one language. What makes the C unbeatable in embedded systems? Secondly, the real world application. We look at examples from car, home, appliances, medical devices and IoT. Third, how C talks to the hardware. I'll show how C accesses memory, registers, timers and peripherals. And fourth one, few examples from the automotive and consumer electronics. And I'll also show you the code snippet how C will access low level registers. And I also show the code snippets how C accesses the low level registers. And I'll also tell you the roadmap to learn the advanced C. And final takeaways. Coming to the next slide, why C? First point is C is the fastest language than another. In embedded systems are small computers inside the machines. They don't have a lot of RAM and CPU power or storage. C is the perfect embedded because it is fast. C compiles directly to the machine code and runs extremely fast. In embedded systems like airbags or anti-braking system, it is speed and also safety. And secondly, it is lightweight. A C program can even run in 4 KB RAM. But if you consider Python, we cannot use less RAM for that and we will have predictable performance. In embedded systems, timing matters. Each and every millisecond matters in embedded systems. Airbag must deploy in 4 to 5 milliseconds. C ensures the deterministic timings. Low level footprint. Every byte matters. In microcontrollers, you might only have 32 KB RAM and C fits perfectly in it. As we discussed, it is a lightweight. And coming to the industry standards, every microcontroller vendor gives C libraries. For example, ST microcontrollers or TI, NXP, Infineon, Qualcomm, like that every microcontroller will give the C libraries for that microcontroller. And coming to the portability, C code works on many microcontrollers with little changes. This is why we use C in embedded systems. Coming to the next slide, where C is used. C is used in automotive systems. In automotive systems, C is used in ECUs, ABS, airbags, power systems, battery management and many more. All these components must react in real time. C is the only safe choice. And coming to the smart devices, smartwatches, fitness trackers, AirPods, smart TVs, TV remotes, these are the devices run on tiny microcontrollers, perfect for C. And coming to the consumer electronics and some home appliances, washing machines, microwaves, refrigerators, AC, water purifiers, these are comes under the consumer electronics in which we use C. And medical devices such as pacemakers, insulin pumps, blood pressure monitors, oximeters, like this in medical devices also we will use C. In IoT, ESP32, ESP8266, STM32, Arduino, like this in every microcontroller we will prefer C. And coming to the next slide. Now in this slide we will compare C with the other languages like Python, Java. If you consider the speed, C will execute within the few milliseconds compared to the Python and Java. The speed is very high. And coming to the memory usage, C requires less memory and Python and Java require more memory. Coming to the hardware axis, with C we can access the hardware directly. It is the privilege in C. But in Python and Java we cannot access the hardware directly. So we will use C in embedded systems. And for real-time supporting, C is the strongest language. And Python is very weak in real-time supporting and Java is moderate. In embedded systems industry, C is the most dominant language rather than Java, Python or any other languages. Python and Java are great languages, but they need big hardware and operating systems. Embedded systems run on 16-bit and 32-bit microcontrollers, 64 KB RAM, low power. Only C fits in those conditions. This is the superpower of C, direct hardware access. In embedded systems, everything is memory mapped. Microcontrollers have fixed addresses, for example, turning on an LED. If you observe this code, we have defined an LED port of register address to 5 and you write one left shift to 5 positions to set the pin number 5. This immediately switches on the LED and connect to the pin. And Python and Java can't do this because they run inside an OS and there is no raw hardware. And coming to one of the real world example, an airbag logic. If the crash is detected and it is greater than the threshold, then it deploys the airbag within few milliseconds, and only C can do this. Coming to the next slide, consumer electronics. Inside microwave, C controls the timer, motor, buttons, display, door sensors, everything. A microwave microcontroller usually has only 32 to 64 KB RAM, and C code fits easily Python cannot even start. And in IoT systems, C is everywhere. In ESP32, Wi-Fi, Bluetooth sensors, timers, all written in C. And coming to the STM32 drivers, automotive grade MCUs used in Bosch, Continental, Tesla ECUs, all are written in C. The Arduino code you write compiles to the C or C++. And wireless tags such as Bluetooth, Wi-Fi, Zigbee, Thread, all implemented in C. Sensors. There are many sensors which take the input from the surroundings like temperature, humidity, accelerometer, sensor drivers and all these sensors drivers are written in C. I'll tell you the simple analogy. Consider C as a manual car. You'll have the full control over it and to low level hardware. And consider Python as an automatic car. It is very easy, but it has limited features. And coming to the next slide, C is future proof. Let me explain. Companies will continue to use C in the future. For example, automotive ECUs. For every automotive system, there is an ECU, and that ECU is written in C language. For every bootloader's firmware updates happen in C based on bootloaders. In RTOS, FreeRTOS, ThreadX, Zypher, in all RTOSs are written in C. For safety control systems such as ISO 26262 automotive compliance, C language is allowed, but other languages are restricted. For chip level programming, MCU vendors optimize everything for C. And let me explain the complete learning roadmap to study C. Coming to the basic, first you need to learn the basics of C such as variable, loop, functions, etc. And then pointers are the heart of the C because to access the low level memory and values, pointers are very important. So you need to learn pointers deeply. Structures and unions, these are the user defined data types. These will help to optimize our code very much. These structures and unions are used in drivers, CAN communications, in many other embedded systems. You need to learn memory management and how you can manage that using C. MCU programming. In embedded systems, we use communication protocols to communicate with each other devices. In that, we will use GPIO, UART, SPI, I2C, timers, ADC, like this. Everything will be written in C. RTOS, real-time operating systems. This is the master which controls the tasks and schedules the tasks. RTOS take care of task scheduling, mutex, semaphores, everything. And after learning all this, you need to build the projects and build your portfolio. Initially, you build a simple project like LED blinking and reading the ADC temperature sensors, using the communication protocols to communicate between two devices, like that. And we came to the end of the presentation and we'll have a brief summary. To summarize, C is extremely fast. C gives the hardware control, it is predictable and real-time safe. 90% of embedded systems run on C. Learning C is equals to opening the door of an embedded automotive IoT aerospace careers. If you master C, your embedded engineering foundations become rock solid. And finally, if you feel this as useful, please like, share and subscribe for more videos like this, and follow at Tag with Yoga on Instagram and subscribe on YouTube. And to watch the complete roadmap to become an embedded system, I already made one video and uploaded in my YouTube channel. Please find that. And if you have any doubts, please comment in the comment section. I will create more videos explaining embedded system concepts in a simple way. See you then, bye.